Welcome to the Knowledge Hub. In today's video, we're going on a journey across the universe to discover 50 mind-blowing facts that will change the way you see the cosmos. From the largest galaxies to the most elusive particles, get ready to explore the infinite wonders of space. Let's get started. Fact 1. The observable universe is 93 billion light-years across. The universe is incomprehensibly vast. What we call the observable universe is a bubble with a diameter of about 93 billion light-years. But here's the thing, the universe itself is expanding, and it's expanding faster than the speed of light. That's why, despite the universe being only around 13.8 billion years old, the furthest objects we can observe are about 46 billion light-years away from us. How is this possible, you may ask? It's because space itself is stretching. The observable universe contains at least 2 trillion galaxies, and each of those galaxies contains millions or even billions of stars. What's beyond the observable universe? That remains one of the biggest mysteries in cosmology. While the observable universe is limited by the speed of light and the age of the universe, we can only speculate on how much larger the entire universe may be. Fact 2. There are more stars in the universe than grains of sand on Earth. Imagine every beach on Earth, every desert, and every grain of sand on the planet. Now multiply that number of grains of sand by billions. That's still not enough to match the number of stars in the universe. Recent estimates suggest that there are around 1 septillion stars in the universe. That's a 1 followed by 24 zeros. To put that in perspective, there are about 100 to 400 billion stars in the Milky Way alone, and that's just one galaxy out of potentially trillions. How did astronomers come up with this number? They observed a tiny patch of sky through the Hubble Space Telescope, known as the Hubble Deep Field, and extrapolated the number of stars from that image. The deeper we look, the more stars we discover, each potentially hosting planets, and who knows, maybe even life. Fact 3. The universe is expanding, and that expansion is accelerating. For much of human history, we thought the universe was static and unchanging, but that belief was shattered in 1929 when Edwin Hubble discovered that galaxies are moving away from us, indicating that the universe is expanding. Even more surprising is the discovery in the late 1990s that this expansion isn't slowing down. It's actually speeding up. This acceleration is driven by something scientists call dark energy, a mysterious force that makes up about 68% of the universe. We don't know exactly what dark energy is, but it's believed to be a property of space itself, causing the universe to expand faster over time. In the distant future, galaxies that are currently visible to us will recede beyond the cosmic horizon, becoming forever out of reach. This poses one of the biggest challenges for cosmologists, understanding the fate of our ever-expanding universe. Fact 4. Most of the universe is invisible. Enter dark matter and dark energy. When we look up at the night sky, we see stars, planets, and galaxies. But what we can observe is only a tiny fraction of the universe. In fact, only about 5% of the universe consists of ordinary matter, the atoms and particles that make up everything we see, from stars to ourselves. The remaining 95% is made up of dark matter and dark energy. Dark matter accounts for about 27% of the universe. It doesn't emit, absorb, or reflect light, making it invisible, but we know it exists because of its gravitational effects on galaxies. Without dark matter, galaxies would spin apart. On the other hand, dark energy is an even bigger mystery. As mentioned earlier, it's responsible for the accelerated expansion of the universe. While we don't fully understand either of these components, their discovery has completely revolutionized our understanding of the cosmos. Fact 5. A year on Venus is shorter than a day on Venus. Venus, often called Earth's sister planet because of its similar size and composition, has some peculiar characteristics. For example, a single day on Venus, meaning the time it takes for the planet to rotate once on its axis, lasts 243 Earth days. Meanwhile, a year on Venus, its orbit around the Sun, takes just 225 Earth days. This means that a day on Venus is actually longer than its year. But that's not the only strange thing about Venus. The planet rotates in the opposite direction to most other planets in our solar system, a phenomenon called retrograde rotation. So, if you were standing on Venus, though you'd be crushed by the atmosphere and scorched by the heat, you'd see the sun rise in the west and set in the east. Fact 6. Neutron stars are incredibly dense. Neutron stars are the remnants of massive stars that have exploded in supernovae. After the explosion, the core of the star collapses into an incredibly dense object, made mostly of neutrons. To give you an idea of how dense neutron stars are, a single teaspoon of neutron star material would weigh about 6 billion tons on Earth. This extreme density results from the collapse of the star's core under gravity, crushing atoms until protons and electrons combine to form neutrons. Neutron stars are also incredibly small, typically just 20 kilometers in diameter, yet they can have masses up to twice that of the Sun. Some neutron stars, called pulsars, emit beams of radiation as they spin rapidly, sometimes hundreds of times per second, creating a lighthouse effect as the beams sweep across the cosmos. Fact 7. There are rogue planets drifting through space. Not all planets are tethered to a star. In fact, astronomers have discovered that there are likely billions of rogue planets in our galaxy, planets that have been ejected from their star systems and now drift alone through the void of space. These wandering worlds can range in size from gas giants like Jupiter to smaller Earth-like planets. Rogue planets are incredibly difficult to detect because they don't emit light or orbit a star that we can observe. They were first hypothesized based on gravitational lensing events, where the gravity of the planet bends light from distant stars, revealing its presence. Some scientists speculate that rogue planets could potentially harbor life, especially if they have thick atmospheres or geothermal heat sources that could sustain liquid water beneath their surfaces. Fact 8. Black holes can evaporate over time. Black holes are often seen as eternal, all-consuming objects from which nothing can escape. However, according to the famous physicist Stephen Hawking, black holes aren't as permanent as we once thought. In 1974, Hawking proposed that black holes emit what is now called Hawking radiation, a theoretical form of radiation caused by quantum effects near the event horizon, the boundary of the black hole. Over incredibly long periods of time, this radiation can cause the black hole to lose mass and eventually evaporate entirely. For a stellar mass black hole, this process would take trillions of years, much longer than the current age of the universe. But for smaller black holes, this could happen more quickly. This idea challenges the perception that black holes are unstoppable forces of destruction and introduces the possibility of them eventually fading away into nothingness. Fact 9. There's a supermassive black hole at the center of every major galaxy. At the heart of nearly every large galaxy, including our Milky Way, lies a supermassive black hole. These black holes are millions to billions of times more massive than our Sun. The one at the center of the Milky Way, called Sagittarius A star, has a mass about 4 million times that of the Sun. How these supermassive black holes form is still a mystery. Some theories suggest they may have formed from the collapse of massive gas clouds in the early universe, while others propose that they grew over billions of years by consuming gas, stars, and even other black holes. What's fascinating is that these supermassive black holes play a crucial role in the evolution of galaxies. They can control star formation by blasting out jets of energy and regulating the flow of gas and dust within the galaxy. Fact 10. The universe has no center or edge. One of the most mind-bending facts about the universe is that it has no center and no edge. This idea stems from the Big Bang theory, which tells us that the universe is expanding in all directions. But unlike an explosion in space, the Big Bang was an expansion of space itself. Picture the universe as the surface of a balloon. As you blow up the balloon, every point on the surface moves away from every other point, but there's no center on the surface where the expansion started. Similarly, if you travel in any direction in space, you wouldn't find an edge. You'd just keep going, possibly forever. This leads to some perplexing questions. Is the universe finite or infinite? If it's finite, what lies beyond it? These are questions that scientists are still working to answer. Fact 11. Time dilation. Time moves slower in strong gravitational fields. Albert Einstein's theory of general relativity tells us that time is not a constant. It can be stretched or compressed depending on the strength of gravitational fields and the speed at which you're moving. This phenomenon is known as time dilation. For example, time moves slightly slower on the surface of the Earth than it does in space because the Earth's gravitational pull warps the fabric of space-time. This effect becomes much more pronounced near extremely massive objects like black holes. If you were to approach the event horizon of a black hole, time would slow down dramatically for you relative to an observer far away. You might experience only a few seconds while years pass for someone else. This mind-bending effect has been confirmed through experiments, such as precise measurements taken from GPS satellites, which need to account for the difference in time between Earth and space to remain accurate. Fact 12. Galaxies are on a collision course, including ours. The universe might be expanding, but that doesn't mean all galaxies are moving away from each other. In fact, galaxies can collide and merge, and our very own Milky Way is on a collision course with the Andromeda galaxy. This galactic smash-up will occur in about 4.5 billion years. Although the idea of galaxies colliding sounds catastrophic, it's not quite as dramatic as you might think. Galaxies are mostly empty space, so when they collide, stars within them usually don't hit each other. Instead, the gravitational forces between the two galaxies cause their structures to distort and interact, often leading to the formation of new stars and planetary systems. When the Milky Way and Andromeda finally merge, they will form a new galaxy. Some scientists suggest it could be named Milkomeda. Fact 13. The coldest place in the universe is a nebula. While we think of space as a cold, empty vacuum, there are regions that are exceptionally colder than others. The Boomerang Nebula, located 5,000 light-years from Earth, holds the record as the coldest known place in the universe. With a temperature of just 1 Kelvin, or -272 degrees Celsius, it's even colder than the background temperature of the universe, which sits at 2.7 Kelvin. How can something be colder than the rest of space? It's due to the rapid expansion of gas being ejected by the dying star at the center of the nebula. As the gas expands, it cools at an accelerated rate, creating this ultra-cold environment. This cosmic refrigerator is an intriguing phenomenon, showing that even in the extreme environment of space, there are places where temperatures drop to unimaginable lows. Fact 14. The universe is filled with cosmic background radiation. One of the most significant discoveries in cosmology was the detection of the cosmic microwave background radiation, CMB, often referred to as the afterglow of the Big Bang. This faint radiation is a remnant from when the universe was just 380,000 years old, a time when atoms first formed and the universe became transparent. The CMB provides us with a snapshot of the early universe and offers clues about its origin, composition, and eventual fate. The radiation is remarkably uniform, but tiny fluctuations in its temperature tell us about the distribution of matter in the early universe, which eventually led to the formation of galaxies and stars. Measuring the CMB has allowed scientists to determine the age of the universe, its rate of expansion, and the existence of dark matter and dark energy. Fact 15. Our solar system is moving through space at 828,000 kilometers per hour. We often think of the planets orbiting the Sun as the main movement in our solar system, but the entire solar system itself is hurtling through space at incredible speeds, In fact, our solar system is moving around the center of the Milky Way galaxy at a speed of about 828,000 kilometers per hour, 514,000 miles per hour. Despite this breakneck speed, it takes the solar system about 230 million years to complete one orbit around the galactic center. This movement is part of the Milky Way's own orbit within the local group of galaxies, which in turn is part of an even larger structure known as the Laniakea supercluster. On top of all this, the universe itself is expanding, causing galaxies to move away from each other at varying speeds, influenced by the mysterious force of dark energy. Fact 16. There are galactic walls of superclusters that span billions of light years. The universe is not just a random scattering of galaxies. It has an intricate, large-scale structure made up of vast chains and filaments of galaxies. These structures are known as superclusters, and they can form enormous walls, stretching across billions of light years. One of the largest known structures is the Hercules Corona Borealis Great Wall, which spans about 10 billion light-years in length. These galactic walls are composed of thousands of galaxies bound together by gravity, but they're not uniformly distributed. Instead, they form a cosmic web with large voids, empty spaces where few galaxies exist, in between. These superclusters are moving apart due to the expansion of the universe, and studying them helps us understand the overall distribution of matter in the cosmos. The existence of such enormous structures challenges some of our assumptions about how the universe formed and evolved, as it suggests a surprising level of coherence and organization on an astronomical scale. Fact 17. The universe is not only expanding, it's expanding faster than light. While nothing can travel faster than the speed of light within space, the fabric of space itself is expanding faster than light. This doesn't violate Einstein's theory of relativity because it's not objects moving through space faster than light, it's space itself stretching. In the most distant regions of the universe, this expansion is happening at such a rapid rate that galaxies are moving away from us faster than light can travel. This is why we can only observe a finite portion of the universe, known as the observable universe. As space expands, more and more galaxies cross the cosmic horizon, effectively disappearing from our view forever. This accelerating expansion is driven by dark energy, and it raises deep questions about the ultimate fate of the universe. Will it continue to expand forever, or will something else intervene? Fact 18. Black holes can merge, creating powerful gravitational waves. One of the most exciting recent discoveries in astrophysics is the detection of gravitational waves, ripples in the fabric of space-time. These waves are produced by cataclysmic events, such as the merger of two black holes. When two black holes spiral toward each other and collide, the resulting event releases a tremendous amount of energy in the form of gravitational waves. These waves were first directly detected by the LIGO Laser Interferometer Gravitational Wave Observatory in 2015, confirming a prediction made by Einstein a century earlier. The detection of gravitational waves opened a new window on the universe, allowing us to hear cosmic events that would otherwise be invisible. Each time we detect these waves, we're gaining new insights into the behavior of black holes, neutron stars, and even the early universe itself. Fact 19. The speed of light is a cosmic speed limit. The speed of light in a vacuum, about 299,792 kilometers per second, 186,282 miles per second, is not just fast, it's the absolute speed limit of the universe. Nothing can travel faster than light. This is because, as objects move faster, their mass increases, requiring more and more energy to accelerate them further. As you approach the speed of light, the energy needed to continue accelerating approaches infinity, making it impossible to reach or exceed this speed. This cosmic speed limit is central to Einstein's theory of relativity, and it has profound implications for our understanding of time and space. For example, at speeds close to the speed of light, time begins to slow down relative to stationary observers, a phenomenon known as time dilation. This is why, in theory, fast-moving astronauts could age much more slowly than people on Earth. Fact 20. The Moon is slowly drifting away from Earth. The Moon is Earth's closest celestial neighbor, but did you know it's slowly drifting away from us? Due to tidal forces between the Earth and the Moon is moving away at a rate of about 3.8 centimeters per year. This might not seem like much, but over millions of years, it adds up. When the Moon first formed around 4.5 billion years ago, it was much closer to Earth, possibly just 20,000 kilometers, 12,400 miles away. Today, the Moon is about 384,400 kilometers, 239,000 miles away. This gradual drift is caused by the exchange of angular momentum between the Earth and the Moon. As the Moon moves away, Earth's rotation is also slowing down, making our days longer by about 1.7 milliseconds per century. In the distant future, this could have significant effects on life on Earth, including changes to tides and the length of the day. Fact 21. Most of the atoms in your body were made in stars. One of the most profound realizations in astrophysics is that we are literally made of stardust. The atoms that make up everything around us, including our own bodies, were formed inside stars billions of years ago. In the early universe, only the lightest elements, hydrogen, helium, and traces of lithium, existed. Heavier elements like carbon, oxygen, and iron were forged in the intense heat and pressure of stellar interiors. When massive stars reach the end of their life cycles, they explode in supernovae, scattering these elements into space, where they eventually become part of new stars, planets, and even living organisms. The calcium in your bones, the iron in your blood, the carbon in your cells, all of it was once part of a star. This cosmic connection means that we are truly part of the universe, both in life and in death. Fact 22. There are exoplanets that might be habitable. Since the discovery of the first exoplanet, a planet outside our solar system in the 1990s, astronomers have found thousands of them orbiting distant stars. Among these exoplanets are some that lie in the habitable zone of their stars, the region where conditions might be right for liquid water to exist, which is crucial for life as we know it. One of the most famous potentially habitable exoplanets is Proxima Centauri b, located just 4.24 light-years away from Earth, orbiting the nearest star to the Sun. Other candidates include planets in the TRAPPIST-1 system, where several Earth-sized planets are in the habitable zone. While we don't yet know if any of these planets harbor life, they are prime targets for future missions and telescopes that aim to detect signs of habitability such as water, atmosphere, or even biological markers. Fact 23. The universe may end in a big freeze. While the universe began with the explosive Big Bang, its ultimate fate might be far more tranquil. One of the leading theories about the end of the universe is called the Big Freeze, also known as heat death. As the universe continues to expand and galaxies move farther apart, stars will eventually burn out, and the universe will become a cold, dark, and empty place. Without the energy from stars, all processes that rely on heat and light will cease. Over unimaginable timescales, even black holes will evaporate due to Hawking radiation, leaving behind a universe filled with only sparse particles and radiation. In this scenario, the universe never ends in a dramatic event. It simply becomes a cold, dead expanse where no significant interactions occur. Fact 24. Some planets rain diamonds. On certain planets, the weather is as bizarre as it gets. Take the gas giants Neptune and Uranus, for example. Deep within their atmospheres, scientists believe that carbon is compressed at such high pressures that it forms diamonds, which then rain down toward the planet's cores. This process occurs because of the intense pressure and temperature in the planet's atmospheres, which can cause methane gas to break down into carbon. The carbon then hardens into diamond as it falls. Similar conditions may exist on some exoplanets, leading to the possibility of diamond rain elsewhere in the universe. While we may never see this dazzling phenomenon firsthand, it's a reminder of how diverse and strange planetary environments can be. Fact 25. The largest galaxy known is 220 times bigger than the Milky Way. When we think of galaxies, we often picture our own Milky Way, but there are galaxies out there that dwarf it in size. The largest known galaxy, IC 1101, is a giant elliptical galaxy located about 1 billion light-years away in the Abell 2029 galaxy cluster. IC 1101 is estimated to be 6 million light-years in diameter, making it about 220 times larger than the Milky Way. It contains more than 100 trillion stars, compared to the Milky Way's estimated 100 billion. How does a galaxy get so large? It likely formed through multiple mergers with other galaxies over billions of years, consuming smaller galaxies and growing to its colossal size. IC 1101 is a testament to the incredible diversity of structures in the universe, showing that galaxies come in all shapes and sizes. Fact 26. Neutron stars are the densest objects in the universe. Neutron stars are the remnants of massive stars that have exploded in a supernova. After the explosion, the core collapses under its own gravity, compressing all the matter into an incredibly small and dense object. A neutron star typically has a mass greater than that of the Sun, but is only about 20 kilometers, 12 miles in diameter. To put it in perspective, just one sugar cube-sized amount of neutron star material would weigh about 1 billion tons on Earth. These stars are so dense because the protons and electrons inside atoms merge to form neutrons. Neutron stars also have incredibly strong magnetic fields and can rotate at staggering speeds, sometimes hundreds of times per second. Some neutron stars emit beams of radiation as they rotate, creating what are known as pulsars, which we can detect as regular pulses of radio waves or other radiation from Earth. Fact 27. White holes might be the opposite of black holes. We've all heard of black holes, regions in space where gravity is so strong that not even light can escape. But did you know that some theories suggest the existence of white holes? White holes would be the opposite of black holes. Instead of pulling everything in, they would push everything out. While black holes are formed by the collapse of massive stars, white holes are purely theoretical and are predicted by certain solutions to Einstein's equations of general relativity. In essence, a white hole could never be entered from the outside, but it would emit matter and energy, perhaps even connected to a black hole in another part of space or time. Some scientists even speculate that the Big Bang could have been a white hole marking the start of our universe. However, no white holes have been observed, and their existence remains speculative. Fact 28. Dark matter makes up about 27% of the universe. One of the greatest mysteries in astrophysics is the nature of dark matter. Despite making up about 27% of the universe's total mass and energy, dark matter remains invisible and undetectable by conventional means. We can't see it, touch it, or directly observe it, but we know it exists because of its gravitational effects on galaxies and galaxy clusters. Without dark matter, galaxies would not have enough mass to hold themselves together, and they would fly apart. Scientists believe that dark matter is composed of particles that interact only through gravity and possibly the weak nuclear force, making them extremely difficult to detect. Understanding dark matter is one of the key goals of modern physics, and its discovery could revolutionize our understanding of the universe. Fact 29. Dark energy drives the expansion of the universe. While dark matter holds galaxies together, dark energy is the force responsible for the accelerating expansion of the universe. Discovered in 1998, dark energy makes up about 68% of the universe's total mass and energy, meaning that the vast majority of the universe is made up of this mysterious substance. Dark energy is thought to be a property of empty space itself, causing space to expand over time. As galaxies move farther apart, the influence of dark energy becomes more dominant, pushing them away from each other at an ever-increasing rate. The discovery of dark energy was one of the most surprising and significant findings in modern cosmology, and it has led to profound questions about the fate of the universe. Will the universe continue to expand forever, or will dark energy eventually slow down or reverse its effects? Fact 30. Some stars are older than the universe, or so it seems. One of the most perplexing problems in astronomy is the discovery of certain stars that appear to be older than the universe itself. The universe is estimated to be about 13.8 billion years old, based on measurements of the cosmic microwave background radiation and the expansion rate of the universe. However, some stars, such as HD 14283, also known as the Methuselah star, appear to be older than the universe, about 14.46 billion years old based on certain methods of age estimation. How can this be? The answer likely lies in the uncertainties in our measurements of both the age of the universe and the stars themselves. Stellar age measurements can be tricky and are based on models of star formation and evolution, which may need refinement. While these discrepancies don't mean the universe is younger than we think, they do highlight the challenges of precisely dating cosmic events. Fact 31. The Sun will eventually become a white dwarf. Like all stars, the Sun will eventually die, but its demise won't be as dramatic as a supernova. Instead, the Sun will go through a more gentle process of aging. In about 5 billion years, the Sun will exhaust the hydrogen in its core and begin burning helium, causing it to swell into a red giant. At this stage, it will likely engulf the inner planets, including Mercury and Venus, and possibly Earth. After shedding its outer layers, what remains of the Sun will collapse into a white dwarf, a small dense remnant about the size of Earth. White dwarfs no longer undergo nuclear fusion, but instead slowly cool and fade over billions of years. This final stage in the life cycle of stars like the Sun is a stark reminder of the ultimate fate that awaits all stars, and by extension, all planetary systems. Fact 32. Rogue planets wander the galaxy without a star. Not all planets are bound to a star. Some, known as rogue planets, wander through space without orbiting any star at all. These planets may have been ejected from their original solar systems due to gravitational interactions or the death of their parent star. It's estimated that there could be as many as 100,000 rogue planets for every star in the Milky Way galaxy, meaning they could far outnumber regular planets. Without the warmth and light of a star, these planets would be cold and dark, but some may still harbor life if they have internal heat sources like geothermal activity. The discovery of rogue planets challenges our traditional views of planetary formation and raises questions about the diversity of planetary systems across the galaxy. Fact 33. Quasars are the brightest objects in the universe. Quasars, or quasi-stellar objects, are the brightest and most energetic objects in the universe, outshining entire galaxies. Powered by supermassive black holes at the centers of distant galaxies, quasars release enormous amounts of energy as matter falls into the black hole, heats up, and emits radiation across the electromagnetic spectrum. Some quasars are so bright that they can be seen from billions of light-years away, making them key probes for studying the early universe. The most luminous quasars can be thousands of times brighter than the Milky Way, despite being much smaller in size. Quasars were first discovered in the 1960s, and they remain one of the most intriguing phenomena in astrophysics, offering insights into the growth of black holes and the evolution of galaxies. Fact 34. The universe is full of cosmic cannibalism. Galaxies are not always peaceful neighbors. In fact, galaxies frequently merge, interact, and even consume one another in a process known as cosmic cannibalism. Larger galaxies, like the Milky Way, often grow by absorbing smaller galaxies that stray too close. Over billions of years, the Milky Way has consumed several smaller galaxies, and it is currently merging with the Sagittarius dwarf galaxy. In the future, it will merge with the Andromeda galaxy. These mergers can trigger bursts of star formation and dramatically alter the structure of the galaxies involved. While the process takes millions of years, cosmic cannibalism is an essential part of galaxy evolution and helps explain why we see such a wide variety of galaxy shapes and sizes. Fact 35. There could be infinite parallel universes. One of the most intriguing and speculative ideas in modern physics is the concept of the multiverse, the idea that our universe is just one of many universes that exist simultaneously. According to some interpretations of quantum mechanics and string theory, there could be an infinite number of parallel universes, each with its own physical laws, constants, and perhaps even different forms of life. These universes might be completely separate from ours, or they could be connected in ways we can't yet comprehend. The many worlds interpretation of quantum mechanics suggests that every time a quantum event occurs, the universe splits into different branches, creating a new parallel universe for every possible outcome. While there's no direct evidence for the existence of parallel universes, the idea continues to captivate scientists and science fiction fans alike as it opens up a mind-boggling range of possibilities. Fact 36. Time could have existed before the Big Bang. The Big Bang is commonly thought of as the beginning of time and space, but some theories suggest that time might have existed before the Big Bang. In one such theory, called the cyclic universe model, the Big Bang was just one of many cycles of expansion and contraction. In this model, the universe goes through endless cycles of birth, expansion, collapse, and rebirth. Another theory, known as the Multiverse model, posits that our universe is one of many, and each universe could have its own distinct timeline. These ideas challenge the notion of a single, definitive beginning to the universe, and raise deep questions about the nature of time itself. While these theories are still speculative, they provide exciting avenues for understanding the origins of our cosmos. Fact 37. The universe might be flat. When we think of the universe, we might imagine it as spherical or curved. However, observations suggest that the universe could actually be flat. In cosmology, the term flat refers to the geometry of space. A flat universe follows the rules of Euclidean geometry, meaning that parallel lines will never meet, and the angles in a triangle add up to 180 degrees. The shape of the universe is determined by its overall density. If the density is equal to a certain critical value, the universe is flat. The cosmic microwave background radiation, which is the leftover radiation from the Big Bang, provides strong evidence that the universe is indeed flat, or at least very close to flat, on large scales. This has significant implications for how the universe will evolve. If the universe is flat, it will continue to expand forever, but at a slower rate over time. Fact 38. The cosmic web connects the universe. The largest structure in the universe is known as the cosmic web, a vast network of galaxies, galaxy clusters, and dark matter that stretches across the cosmos. Galaxies are not evenly distributed. Instead, they are arranged in a web-like structure with vast voids in between. This cosmic web is made up of filaments of dark matter and galaxies, with intersections where galaxy clusters are located. The cosmic web forms as a result of gravity pulling matter together over billions of years, while dark energy pushes galaxies apart. This structure is so enormous that it spans billions of light years and gives us a glimpse of the large-scale architecture of the universe. Studying the cosmic web helps scientists understand how galaxies form and evolve, as well as the role of dark matter and dark energy in shaping the universe. Fact 39. The observable universe is only a tiny fraction of the whole universe. When we talk about the universe, we often refer to the observable universe, the part of the universe we can see and measure. The observable universe has a radius of about 46.5 billion light-years, meaning that light from the most distant objects we can observe has taken 13.8 billion years to reach us, the age of the universe. However, the observable universe is only a tiny fraction of the entire universe. Due to the expansion of space, there are regions of the universe that are beyond our reach, and their light will never reach us. Some theories suggest that the universe could be infinitely large, or at least much larger than what we can observe. This means that we might never know the true size of the universe, leaving many mysteries about its total expanse. Fact 40. Black holes can slow down time. Black holes are notorious for their ability to warp space and time due to their extreme gravitational pull. According to Einstein's theory of general relativity, as you approach a black hole, time slows down relative to an observer far away. This phenomenon is known as gravitational time dilation. If you were to watch someone falling into a black hole, you would see their movements slow down more and more as they approached the event horizon, the point beyond which nothing can escape the black hole's gravity. From the perspective of the person falling into the black hole, however, time would appear normal. This effect becomes extreme near the event horizon, where time could appear to stop altogether from the viewpoint of a distant observer. The study of black holes and their influence on time is a fascinating intersection of quantum mechanics, general relativity, and cosmology. Fact 41. The farthest object we can see is 13.4 billion light-years away. The most distant object ever observed by astronomers is a galaxy called GNZ11, which is located 13.4 billion light-years away. This galaxy is so far away that we are seeing it as it was only 400 million years after the Big Bang. Observing such distant objects allows us to peer into the early universe, helping us understand how the first galaxies and stars formed. GNZ11 was discovered using the Hubble Space Telescope, and its extreme distance makes it one of the most important objects for studying the universe's infancy. As technology improves, future telescopes like the James Webb Space Telescope will allow us to see even farther, potentially revealing galaxies that formed even closer to the Big Bang. Fact 42. The Milky Way and Andromeda are on a collision course. In about 4.5 billion years, our galaxy, the Milky Way, will collide with the Andromeda galaxy, our nearest large galactic neighbor. Despite both galaxies being full of stars, the vast distances between stars mean that individual stars are unlikely to collide during this galactic merger. Instead, the gravitational forces will pull the galaxies into new shapes, potentially creating a giant elliptical galaxy. This merger, sometimes called Milkometa, will radically change the appearance of both galaxies. The supermassive black holes at the centers of both galaxies may eventually merge as well. While this event is far off in the future, it offers a glimpse of the dynamic and ever-changing nature of galaxies over cosmic timescales. Fact 43. The Hubble Deep Field revealed thousands of galaxies in a tiny patch of sky. In 1995, astronomers pointed the Hubble Space Telescope at a seemingly empty patch of sky in the constellation Ursa Major. For 10 consecutive days, the telescope captured faint light from this tiny region, which appeared devoid of stars or galaxies. The resulting image, known as the Hubble Deep Field, revealed thousands of galaxies, some as far as 12 billion light-years away, packed into a tiny slice of the sky. This discovery was revolutionary because it showed that even the most empty parts of the sky are filled with galaxies, many of which formed shortly after the Big Bang. The Hubble Deep Field has been followed by even more detailed surveys, such as the Hubble Ultra Deep Field, further expanding our view of the early universe. Fact 44. Our universe might be a hologram. One of the more mind-bending theories in modern physics is the idea that the universe might be a hologram. This theory, known as the holographic principle, suggests that all the information contained within a region of space can be described by data on a lower dimensional boundary, much like a hologram projects a three-dimensional image from a two-dimensional surface. In this view, the entire universe could be seen as a projection from a lower dimensional reality. This concept is closely related to string theory and the study of black holes, where information about objects falling into a black hole seems to be stored on its event horizon, not inside the black hole itself. While the holographic principle is still highly speculative, it has opened up fascinating possibilities for understanding the nature of space, time, and reality. Fact 45. The universe may end in a big freeze. One of the possible fates of the universe is the big freeze, also known as the heat death of the universe. In this scenario, the universe will continue to expand indefinitely, with galaxies moving farther and farther apart. Over time, stars will burn out, galaxies will grow dark, and black holes will eventually evaporate due to a process called Hawking radiation. In the far, far future, trillions of years from now, there will be no sources of heat or light, and the universe will reach a state of maximum entropy, where no more useful energy is available to do work. The universe will become cold, dark, and lifeless, with only sparse particles drifting in the empty void of space. While this grim ending is still speculative, it is one of the leading theories about the ultimate fate of the universe. Fact 46. Galaxies can travel faster than light. While nothing can travel faster than the speed of light in a vacuum, the expansion of space itself can cause galaxies to move away from each other at speeds greater than light. This happens because space is expanding everywhere at once, so the farther away a galaxy is, the faster it appears to be receding from us. Galaxies that are beyond a certain distance from us are moving away so quickly that their light will never reach us, effectively placing them beyond the observable universe. This phenomenon does not violate the laws of physics, because it is not the galaxies themselves that are moving faster than light, but the space between them that is expanding. Fact 47. The universe might have more dimensions than we can perceive. We experience the world in 3 dimensions of space and 1 dimension of time. But some theories suggest that the universe may have additional dimensions beyond these 4. In string theory, one of the leading candidates for a theory of everything, the universe may have up to 10 or 11 dimensions, with the extra dimensions being curled up so small that we cannot perceive them. These hidden dimensions could help explain some of the fundamental forces of nature, such as gravity and electromagnetism. While we cannot directly observe these extra dimensions, their existence could have subtle effects on the universe that might be detectable in future experiments. Fact 48. We might be living in a multiverse. The concept of the multiverse suggests that our universe is just one of many universes that exist simultaneously. In the multiverse model, each universe could have its own set of physical laws, constants, and properties, leading to a vast diversity of possible worlds. Some versions of the multiverse arise from quantum mechanics, where every possible outcome of a quantum event spawns a new universe. Other versions are tied to inflationary cosmology, where different regions of space stop inflating at different times, leading to the formation of distinct bubble universes. While there is currently no direct evidence for the multiverse, it remains an intriguing possibility that could radically change our understanding of reality. Fact 49. The universe is full of invisible matter. Most of the matter in the universe is invisible to us. This mysterious substance, known as dark matter, does not emit, absorb, or reflect light, making it undetectable by telescopes. However, we know it exists because of its gravitational effects on galaxies and galaxy clusters. Dark matter makes up about 27% of the universe, while ordinary matter, everything we can see, makes up only about 5%. The rest of the universe is composed of dark energy, a mysterious force driving the acceleration of the universe's expansion. Scientists are still trying to understand what dark matter is made of, and its discovery would be one of the most significant breakthroughs in physics. Fact 50. The universe was born in the Big Bang, but its future is still uncertain. The Big Bang marks the beginning of the universe, but what happens next is still a subject of intense study. Will the universe expand forever, or will it eventually collapse in a big crunch? Could the expansion slow down and reach a steady state, or will it continue accelerating until the universe experiences a big rip? These questions depend on the properties of dark energy, which makes up about 68% of the universe. As we learn more about dark energy, we may be able to predict the universe's ultimate fate. For now, the future of the universe remains one of the greatest mysteries in cosmology. Thank you for joining me on this incredible voyage across space and time. If you enjoyed this journey through the cosmos, make sure to give this video a thumbs up, subscribe to the Knowledge Hub, and hit the notification bell so you won't miss out on future videos where we dive into more fascinating topics about our world and beyond.